Okay, if we take a look at the example 3 and 4 here, just some more practice with it. Hopefully you've tried working ahead and just check in with your answers, make sure you got the right ones. Here we're looking at Amy. She's diving off a springboard this time. Her height above the water is related to how far she is from the end of the board, right? And we have this equation. I'm going to use my technology to save me the work. I'm going to get rid of the old ones. I'm going to put in a new one. So y equals, what do we got this time? Negative x squared plus 3x's plus 4. There we go. I move that around a little bit, not a good spot for me to see it. There we go, I can see that. Kind of looks like a diving board, right? The parts that we care about, again, pretty much this section, right? And our equation, our graph will be more than that always, but we only really care about some parts of it. All right, what do we need to know? How far from the board does Amy land? Well, she lands where she hits the water, where the 0 is. So that would be 4. That was quick and easy. Okay, so we can say part A, 4 meters from the board. All right, part B, what's the maximum height that she reaches and how far from the board is she? Well, that sounds to me kind of like the vertex. The maximum height over here, I got 1.5 and 6.25. Okay, which one's which? 1.5 and 6.25. Okay, this is our height right here, and this is how far she is from the board. There's our meters, right? So what's the maximum height? Max of 6.2 meters when she is 1.5 meters from the board. And technology goes real quick for us here. And part C, when she first steps on the board, how high above the water is she? We'll take a look at our picture. She steps on the board right there, and her height is 4 meters. And we're done. Okay. Give the last one a try if you didn't try that one. See if you can figure it out. This is a little bit trickier, but you should be able to get it. Okay, let's get rid of what we don't want. What are we putting in this time? Oh, we got some decimals this time. Oh, P's and T's. Our graphing calculator is built with Y's and X's, so we have to think about which one should be which. And common sense says my P should be the Y value and the T's should be X's, right? Based on what we've been doing the whole time. Okay, so we can put in the same equation. Just think about, okay, X is my T value, X is my T value. 7.2X, and then plus 100. Oh, and my picture doesn't even show up. So what do I have to do? I need to zoom out. Let's get this thing going here. Oh, there's my picture. Okay, I got myself a nice, lovely picture. I can see some stuff. What do they want me to do? Let's read this. The population of a town described by that equation. P is the population in thousands, and T is the time in years since, where T equals 0 is 2000. Okay. So, what was the population in the year 2000? Well, that's where my T is 0, right? It's my initial value. So let's go take a look at our initial value on this thing. That looks like this dot right down here at the bottom. So my population at time 0 is 100. Now remember, they told us the population was in thousands, so it'd actually be 100,000, right? Okay, part B. When will the population be in 2010? So that's 10 years later, so that's when my time is 10. And I suppose I could use my equation and figure out, okay, what's 10 squared plus 7.2 times 10 plus 100. That would have worked totally fine. But wouldn't it be faster just to go to my graphing calculator, my technology here, make a new equation, say, hey, what happens when x is 10? Okay, where is x 10? Let's take a look at this thing here. X is 10. Okay, let me move that one out of the way, I can't see. That looks about right there. Let's see if I can find a nice gray spot there. Oh, 10 and 0, I don't want that one. Get rid of that one there, get off that. There it goes, there's my 10. 188. Okay, so this is 188. Again, I could have put in the calculator, but the technology did it for me. Don't forget it's in thousand. These are 188,000 people, right? All right, when will the population reach 520,000? So let's say we know the p value, we want to find the t value. Okay, so I know the y, if you will. So I'm going to put an equation in for y. I want to know when I hit 520,000. Well, if I go to do that, if I put 520,000, I got a problem because my question's in thousands. So my y value isn't 520,000. It's actually just 520, right? Because that represents thousands. Where's my intersection? It's right about there. Find that dot, 33.458. So it's going to take 33.458 years to reach 520,000. Okay, and there's how we can use some technology. So there's just a couple quick quadratic questions you can try using the technology again for your test. You'll have access to either your phone, the iPad, a computer, somewhere you can go and use this technology. Okay, I'll arrange that with the teachers supervising you.